Okay, let's see if we can't get people on this live session, grade 8, grade 9, whatever grade these people will be in. Let's check if there are any people that are actually home, or are all people not home and people are at school slaving away. If the people are at school slaving away, that's great. I'm very happy. Smuta Sako, you are always here. I literally believe that you literally live at the gate of my live sessions. So the minute I begin to open the gate of my live sessions, you are like literally here in no time, Mr. Smuta Sako. So I don't know. It's like you are living at the gates of my live sessions. Is that true? Alright guys, I had promised the grade 8s and 9s that I'll be back here at 20 past 8, but I'm telling you, as surely as things happen in life and things don't quite go according to the way that you've planned, that's exactly what happened. Things did not really go according to how I had planned. So as a result, I am here, but the reality is that as I am here, I am not here, at the time that I had said that I would be here. Okay, so I just want to get a feeling as to the people that I hear, which grade are the people that I hear in, so that if the grades are not the grades that I'm actually really looking for, then maybe I can actually steer away to something else, or maybe, fine tune or, do something that will be relevant to the individuals that are here. If there's any specific thing that you'd like to maybe ask, or maybe something that you'd like clarity on, then I'd hope that you would indicate there in the comment section that I'm in this grade, can you help me with this? Or I can actually answer the questions that I have here before me, which are geometry type questions, all right? And I can basically lead us in that. This is for both grade 8 and grade 9. Understanding fully well, guys, that some of you are here, but some of you are at school and you can't join the live lesson, or maybe some of you are in the thick of things, writing a particular exam. Is the network okay first? Let's start there. Is the network fine? Am I audible? Can you hear me? Can I answer these questions? Or is there something else you'd like assistance or help with? Hello? Is anybody home? Oh, there we go. There we go. Network is always an issue, Gengo, here. I need an indication if the network is fine. Must I proceed and answer these questions that I hear? Or is there something else that people want me to do in this live? Okay, am I audible? Can you hear me? Is the network okay? Okay, you can hear me properly. But now I need to understand, should I answer? Should I proceed with this geometry? Or is there something else that people here are interested in having done at this present moment? Okay, the noise is going to get very loud now because learners are finishing writing. Proceed, okay. All right, guys, here we have this particular two-dimensional thingamabob. So AB, there's this arrow, okay? Then there is DC. There's that arrow. What do the arrows mean? The arrows mean the lines are parallel. Means that the lines are what? Are parallel. We want to find the value of what? We want to solve for x. Okay? And we are asked to show all our calculations and give what? Reasons. So how do we find x? Okay? This angle here that we are given is 2x plus 30 degrees. Okay? Okay, so grade 8 and 9, if you're in grade 8 or 9, this is relevant for you. Then this angle here is 3x plus 10 degrees. So what is the relationship of these angles? Mbazo says the relationship is corresponding angles. You are 100% correct. These two angles, we call them corresponding angles. Why do we call them corresponding angles? What is the basis of us saying that these are corresponding angles? It is because of the position that these angles occupy. This angle and these angles, we refer to them as corresponding because of the F shape. Very good, Buddha. You heard me very well yesterday when I said top of this line, this angle, on the same side of the transversal line, then on top of the other line. These two angles have a relationship of what? Of corresponding angles. Top. Then we say that these two angles are actually equal. Why? Because of the lines that are parallel. AB is parallel to DC. So then we can write the following in our statement. 3x plus what? Plus 10 degrees is equal to what? 2x plus what? 30 degrees. Then in brackets we must provide an reason. Corresp angles. Okay. We write corresp angles. This is short for corresponding angles. Then which lines are parallel? Remember, we said that the angles are only equal as corresponding angles. If what? If the lines AB and DC are parallel. So we need to then say and provide the parallel lines. AB is parallel to DC. Okay? Then now, if we have this, guys, my statement is correct. My reason is correct fully because I have corresponding angles and I've also provided the lines that are parallel. If you don't provide parallel lines, guys, then your reason is not complete. Okay? I hope you understand me. Now, we go and apply what we learned in term 3 or term 2, which is to solve for x. So 3x plus 10 degrees is equal to 2x plus 30 degrees. Guys, remember that these angles here, we say that these angles are in terms of x. This angle is 2x plus 30 degrees. It is in terms of x. Why? Because 2x plus 30 degrees is an angle that consists of two terms. It has a variable x with a coefficient 2, and then the plus sign separates the 30 degrees, and this basically is an angle that is having terms that have x in it. That's why we say these are angles in terms of x. And 3x plus 10 degrees is also an angle in terms of x. Now we can solve for x. We are going to make sure that like terms are isolated or they are alone together. So we take this 2x, it crosses over the equal sign. The 2x, which is positive, changes to minus 2x and it joins its like term. 30 degrees. Okay, it is on the right. 10 must cross over. It joins its like term. Positive 10 changes to a negative 10 degrees when we transpose to the right hand side. Then we add and subtract the like terms that we have. What is 3x minus 2x? When you add and subtract like terms, you keep the variable as it is, and then you add and subtract the coefficients. So what is 3 minus 2? It is 1. So you have 1x in other words, which is equal to what? 30 minus 10 is 20 degrees. What is the coefficient of x? It is 1. That one, we don't necessarily have to actually write it down. Why? Because yes, the 1 is present, but just like the Holy Spirit, it is like that x is acknowledged that it is there, but it is invisible to the physical eye. Why? Because x is the representative that basically the Holy Spirit sends to declare the message. Just like the Holy Spirit one time sent a biblical messenger called Moses to go and deliver the children of Israel out of bondage. So when the Holy Spirit has a legal physical representative, it basically operates invisibly through the physical member that is representing it on the earth. So x is equal to 20 degrees, guys. So that 1, it is there, just like the Holy Spirit is there, but we do not see it. Okay? So that is how we get that answer. So you get a nice, beautiful third final mark for the answer, and oftentimes the simplification as well. You get a mark for that one as well. I hope that was simple and nice and straightforward, and the geometry is starting to flow very nicely, and you are clear as daylight. Let us answer another question, and this will most probably be my last question, guys. The noise is getting very loud, and I have a class that I need to convene for my grade 9s here where I'm at, so I need to actually end this live after this lesson. They finished quickly writing their exam that they are writing today. So let's look at this one now. We still need to solve for x. So let's check what is the relationship we have. We have this angle, which is x plus 10 degrees. All right. And we have this angle, which is 2x minus 10 degrees. Okay. So I hope that is clear. Okay. Then WT is equal, you have this line to what? To RT. So you have this equal for sides that are equal for the triangles, which means we have an isosceles triangle here. We have lines that are parallel. Okay. And we also have lines that are parallel here as well. Okay. So I hope we are clear here what we are seeing, and we are very, very much understanding what is there. Okay. So from what I can see here, this line is parallel to this one. That therefore means to me that this angle and that angle are actually what, guys? Okay, for both grade 8 and 9 in this paper, this angle and that angle, since these lines are parallel, we say that these angles are what, guys? They are alternating angles. Very true, because we have a what? A Z shape, guys. A Z shape. Okay, so the Z shape gives us angles that are alternate. So we can clearly see. Thank you, Pabi, for the rose. I really appreciate it. Pabi, thank you so much. You be blessed. You be blessed. So we can find angle R first. Okay, our goal is to solve for x. So it would be good for us to find angle R using the idea of parallel lines. X plus 10 degrees, which is angle PQR. So in other words, angle PQR I can see is x plus 10 degrees. That angle PQR, which is equal to x plus 10 degrees, is also actually equal to angle who? Angle, now I'm going to be specific about this angle R. I'm going to say TRQ, TRW, TRW, TRW. Yeah, you see, Mushi, there is a strategy we are using deliberately here because of the information that we have. We are supposed to, we were to basically say 2x. We are going to solve for x. We have is a situation where Our x's, they cancel. We have 0 on the left and 0 on the right. So basically, we need to use the whole diagram so that we can push the agenda of the fact that, okay, if there's an x plus 10 degrees here, this x plus 10 is obviously equal to what? To angle TRW. So then we have that x plus 10 degrees there, so that we can then use this angle and that angle, using the fact that these sides are equal, to then equate these two angles and solve for a x that will actually be available. So PQR is equal to angle P, like I said, QR is equal to x plus 10, which is actually equal to what? To TRW, this angle. What is the reason for saying that? The reason is alt angles. But then we need to be cautious to identify the lines that are parallel. Alt angles is not enough as a reason. We need to also then say QP is parallel to TR. We can see the two arrows. So we say QP is parallel to what? TR in that direction. Okay. So far so good. We then update our diagram. We update the diagram according to what we've just found. Does that make sense? So this angle R, TRW, is equal to x plus 10. Now there's a relationship that we have between this angle and that angle, seeing as though we have a triangle where these sides are equal. What do we know about this angle and that angle? Okay, this angle and that angle, because of this triangle. Angle TWR and angle TRW, what do we know about them? Yes, Mushi, we know that these angles, they are equal. What is the reason? So let us write it down. TWR, angle TRWR is equal to angle TRW. Okay. Why are those two angles equal? They are equal because angles opposite equal sides. Okay. Yes, I know this is an isosceles triangle, but the reason we use for these angles being equal is angles opposite equal sides. Angles opposite equal sides. Okay. Then I can go ahead and solve for those angles. 2x minus 60 degrees is equal to x plus 10 degrees. Now I can take these two angles and solve for who? For x. Then I'm going to say 2x. Okay, take the x over, minus x. Okay, is equal to 10. Transpose the 60, which is negative. Remember, the 60 is negative. So when I transpose a 60 that is negative, what happens when I write it this side? It becomes positive 60. Then from there, I can solve. What is 2x minus x? That obviously gives me 1x. What is 10 plus 60? That gives me 70. So therefore I can conclude that x is equal to what? 70 degrees. And that's done. Okay. Yeah, nice simple marks there. But you see, when we know our stuff, then we can do what needs to be done and get the final simple marks. Those who are asking which grade, this is grade what? Grade beautiful 9. Grade beautiful 9. Now I want to check some knowledge that we should have, that I think we should have, grade 8s and 9s. Let's see if we understand the following. It says complete the following geometrical statements. The complement of 63 degrees is the complement. Guys, do you know what the complement is? What is a complement? What is a complement? Okay, look at this. Hunter, very good. Sbuta Sako, very good. So the word complement means, okay, the angle which we would add to 63 degrees to give us what? 90. That angle that you would add to 63 degrees to give us what? 90. So what is the complement of 63 degrees? As you guys have said, it is 27 degrees. Very good. Let's move on to another one. In an obtuse triangle, the one angle is, repeat, in an obtuse triangle, the one angle is, the one angle. Okay, to say it is obtuse does not explain anything. It is obtuse, then you need to also actually explain the meaning of obtuse. Okay. In an obtuse triangle, the one angle is Samke. That's not necessarily true. Mushi, not even. Small, very good. Thank you so much. Small and Hunter, you have now answered correctly. In an obtuse triangle, remember the word obtuse means something to you. So if you're going to say in an obtuse triangle, the one angle is obtuse, that's not good enough. Unless you would say is obtuse, and then in brackets, you actually write greater than 90 degrees. Then you are speaking to me. But you can't just write obtuse, because whoever's marking you, they are asking themselves the question, does this person even understand what the word obtuse means? Okay, so you could write it, your answer, in two ways. You could write obtuse and then in brackets indicate that greater than 90 degrees. The one angle is greater than 90 degrees. Or without obtuse, you could say in an obtuse triangle, the one angle is greater than 90 degrees. That makes a whole lot more sense than you just saying obtuse. So please, if you do write obtuse, let there be a bracket explanation so that whoever's marking you can understand that you understand what the word obtuse means, you know. Let's go here, 1.1.3. In any triangle, the longest side is opposite the. In any triangle, the longest side is opposite the. Hunter, Klein, Noble. Okay, I'm finding it hard to approve your comment. I see what you've written. You have said in any triangle, the longest side is the largest angle. I'm very happy that you've indicated that, because that is true. In any triangle, guys, the longest side is opposite the largest angle or the biggest angle. Okay, so if you say the biggest angle, or you say the largest angle, okay, you would be 100% correct. Okay, the longest side is always opposite the biggest or the largest angle. If you didn't know that about a triangle, now I am telling you. The longest side in whatever triangle you have will always be opposite your biggest or your largest angle. Don't ever forget that, now and forevermore. Let's move on to the next question. The sum of the adjacent angles. What does sum mean? It means total. The sum of the adjacent angles. That's what does adjacent mean? Adjacent is speaking to angles that are next to each other, that are sharing a common vertex, that are next to each other, sharing a common vertex on a straight line. The sum of the adjacent angles on a straight line is, Moshi says 180 degrees, says Buta Sako says 180 degrees. You guys are 100% correct. So if you write this 180 degrees, or you write the word supplementary, that is also fine. Okay, that is also fine. Yes, Hunter Klein, very true. In a right angle, the longer side is the hypotenuse, right? Yes, it is. And it is opposite the 90-degree angle. Yes, that is true. Okay, that is true. Okay. But for 1.1.3, it says in any. So we are just talking about any random triangle here. Whatever longer side is in that triangle will always be opposite the biggest angle. Okay. 1.1.5. Okay, 1.1.5. Do you do online classes grade 12 for next? Is it, are you saying next year? So I'm assuming your daughter is in grade 11 at the moment, and your daughter will be in grade 12 next year. I do online classes, I do. All right, you can just message me on the side, send me a message on the side, we can chat privately in my inbox. Yeah, that's fine. And if I may ask, Bongani, how's the daughter doing in preparation for the exam now? Have they written grade 11 paper 1 and paper 2? Are they writing grade 11 paper 1, paper 2 yet? Still? And when? I'm going to be having a live session tonight from 8 to 12 p.m. That's if they are not preparing for another exam. But if not, just indicate. Maybe in the message when you send me, you can also indicate that. 1.1.5, a triangle with 3 equal angles is called a what? A triangle with 3 equal angles is called a what? You guys have said it correctly. It's an equilateral triangle. Very good. Not a reflex. It's equilateral. Remember, the word equi means equal. Lateral means line or side. So basically, it's equal sides of a triangle. It's called an equilateral triangle. 1.1.6. An angle between 180 degrees and 360. Oh, I see, Wood. You are answering the next question. An angle between 180 degrees and 360 degrees is a very good, Leo. Very good, Wood. LJ, no, it's not a right angle. An angle between 180 and 360 is called a very good, Clinton. Very good, Moshi. I have some brilliant, amazing, smart people in the live today. I'm telling you, the comment section is booming, man. It's booming intelligence, smarts, and all sorts. It's phenomenal. I'm mind blown. So an angle between 180 and 360 degrees is a very good, guys. It's a reflex angle. You guys have said it 100% correct. Moving right along. The spelling error is funny here. In an equal. This is so funny. So in the place of A, English students, you know it's supposed to be I there. Okay, I'm sorry for the noise, guys. You're just going to have to bear it. There's gonna be some noise for a little while, so it just is what it is. Situation, kids have just finished writing, so yeah. In an equilateral rectangular triangle, the size of the angles in degrees are. Oh man, this is so funny. This is so hilarious. Okay, I think in all honesty, I think there is all sorts of writing crazy errors here. All sorts of crazy errors, guys. Sorry, I'm sorry about this. I think, specifically speaking, I think what they did want to say is that they wanted to say in an equilateral triangle, the size of angles in degrees are. They wanted to say in an equilateral, okay? But it's just that, you see, they wrote equal, and then they wrote lateral, and they wrote rectangle. So there's just all sorts of things here, and then a featuring another word here, you see. Yeah, because they didn't so let's just forgive these people for this, okay? Forgive this part, all right? Because I just took this paper from somewhere. So this statement should say in an equilateral triangle, the size of the angles in degrees are 1, 2, 3. So you guys are 100% correct. 60 degrees and 60 degrees and 60 degrees. That should be what we should have. 1.1.8, the supplement of x degrees. The what? The supplement of x degrees is what? The supplement of x degrees is what? What do we add to x to get 180? Remember, we said the complement of 63 is 27. Wow, Hunter, very nice. Clinton, Levin, and Hunter are on the money there. So if we have a numerical value, it's very easy to think of. If we are asking the complement of 63 degrees is what? What we are asking ourselves is 63 plus what gives you 90. So it's very easy to say 27, right? It's very easy to solve for this unknown. Are we together? Now, all of a sudden, they are saying the supplement. First and foremost, what is supplementary angles? Supplementary angles are angles that add up to 180. So in other words, they are saying the supplement of 180, meaning what do we add to x to get 180? Does that make sense? Just like here we had said, what do we add to 63 to get 90? Because we wanted the what? The complement. Because complements make up complementary angles, which are angles that add up to 90. Now we are asking, what is the supplement of x? Meaning we are asking, what are the two angles we will add together? In specifically, what are we going to add to x to get 180? So if you were to, let's say, isolate this guy on the left alone, you take the x over. You remember, we are trying to find what's here. We take the x over. It becomes 180 degrees minus x. So what is supposed to be in the box? The box is equal to 180 minus x. That is the supplement of x. Let's check it out. What is x plus 180 minus x? When you add these two together, what's x plus 180 minus x? I'm sure you can see the like terms. X minus x gives you what? 0. What are you left with? Just 180 degrees. Okay. So I repeat again. The supplement of x is what? Aye, guys. As surely as the people that commented and said it's 180 minus x, the supplement of x is going to be 180 degrees minus x. Add these two together, they should give you supplementary angles. Meaning if you add x with 180 minus x, you will see that, oh, indeed, this is the supplement, because when I add this x to this, the x minus x becomes 0. I'm left with 180, which means indeed 180 minus x is my what? Is my supplement. Let's go here. If x and y are vertical opposite angles, x minus y is equal to, very good guys, I see you in the comment section, x minus y is equal to 0. Very good. You see, they're asking this question, very, very interesting. X minus y is equal to 0 degrees. Let's not forget that degrees, very important. Because when I take this minus y over, what happens? It becomes positive y. So x is equal to y when I have the y on the other side. And that is true for vertically opposite angles. So yes, it's x minus y is equal to what? To 0. Let's look at this, I think, concluding question together. Calculate the value of x. Yes, Clinton, that example is beautiful. Like 45 minus 45 gives you 0, or 35 minus 35 gives you 0, or 11 minus 11 gives you 0. Calculate the value of x if 2x minus 40 degrees and 4x plus 10 degrees are co-interior angles. I have a bit of a problem with this particular question, because in the statement they should have at least said to us. Remember, I said co-interior angles exist whether lines are parallel or not. They should have, because they want to lead us somewhere, they should have said calculate the value of x if 2x minus 40 degrees and 4x plus 10 degrees are co-interior angles between two parallel lines. You see, when they omit to indicate this, then even the person who is asking the question is not really with what we are trying to emphasize when we teach the concept of co-interior angles, corresponding angles, and alternate angles. So this would need to also feature in our statement in order for it to fully make sense to the learner, so that they can answer and then be able to say these two angles, they are actually supplementary. Guys, co-interior angles are not always supplementary. I repeat, co-interior angles are not always supplementary unless they lie between what? Parallel lines. Hence the emphasis that they need to be between parallel lines. Please, 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 those angles need to be situated between parallel lines. So I would have had an issue with this statement, to be honest, and I would have had an issue with the person who actually formulated this question. Anyways, that's besides the point. So knowing that they wanted to ask this, obviously in light of parallel lines, we are going to answer their question. That means, in other words, 2x minus 40 degrees plus 4x plus 10 degrees is equal to what? To 180. Why? Because co-interior angles that lie between parallel lines are actually what? Supplementary. Then we write the reason. Co-int angles. Then we state our parallel lines. Then in our we take 2x, we add it to the like term 4x, we take the 180 degrees, we transpose the 40 and the 10, the minus 40 becomes plus 40, the plus 10 becomes minus 10. We become very alert of the signs, guys. You know, plus 10 on the left was positive. When it goes over, it becomes negative. Negative 40, which was negative, becomes positive 40. I already saw, guys, that your answer, is already what it is. 180 plus 40 is 220. 220 minus 10, 220 minus 10 is 210. Okay, together so far? Hey, I hope we are together. Then what do we do after that? I'm sorry, guys, for the network. The network is bad. I'm very sorry about that. Network is bad for all of us. Is it? Very sorry about that. The network is bad. I'm very sorry. Very sorry. O and N is asking, how did I get O and N? First and foremost, do you understand how I said 2x minus 40, then added 4x plus 10, and said that is all equal to 180? Do you understand this first? That this statement is based on the fact that these two angles we are told are co-interior angles. And then the reason for saying that is because of co-interior angles, and given that the statement would have been complete, we would say we would include the parallel lines, which we have not been given, but we would still include the symbol for parallel lines. Then we add like terms. In algebra, we know that there are what we call like terms. 2x and positive 4x are what we call like terms, because these terms, as separate as they are, they have variables of x, both of them. So we group them together. We take 2x and add, because there's an addition sign before the 4x, so we add 4x. If there was a minus sign before the 4x, we would subtract 4x, but there's an addition sign. When we group terms together, we should still allow them to keep their signs. 2x was positive, 4x is also positive, so it keeps the sign. We take the 10 on the left hand side, it crosses over, it becomes negative. We take the negative 40 on the left hand side, it crosses over, it becomes positive 40. We add the degrees. 180 plus 40 is 220, minus 10 is 210. This side, what's 2x plus 4x? It is 6x. When we add like terms, guys, what do? We keep the variable of the like term as it is when we are adding or subtracting like terms. So in the answer, x will feature as it is. Whenever you add like terms, the variable stays that way. Then you add and you subtract the coefficient of the variable. Since the coefficient here is 2 and the coefficient here is plus 4, when you add 2 plus 4, you get 6. That is the coefficient answer. It's 6. The variable does what? It stays the same. So O and N, I hope you are fine. I saw you approved when my other friend there in the comment section, Moshi, explained to you. Then 180 plus 40 minus 10 is 210. Now that we are here, we want x alone. We want x to be alone. We want x to be lonely. Like you are lonely in your room right now studying for your exams. You have to be alone, guys, in order to find the solutions that you will use as solutions where in your exams when you write. If you don't learn to be alone, you are going to have a problem. Okay, so this 6 that is multiplied to x, we get rid of it by dividing by the very 6 that was there. So we divide by the coefficient of x, which is 6. Why? Because 6 has a relationship with x of multiplication. That is what combines the 6 and the x together. The 6 and the x are multiplied, thus combining them together. So 6 multiplied by x, how can you get rid of the 6 that is multiplied by x? It's by dividing by the same coefficient. If it was negative, I would divide by the same negative coefficient. But since 6 is positive, I divide by the same 6 coefficient. But remember what you do on the left. Singena ubani 11 to 3. Bacelele nabanye. So ngu-10:28, 11 to 3. Yeah, so ngu-10:28 zanika 30 minutes, but 11. Both not to 3 really, but 11 mhlambi to 12:30. Yeah. So we divide by 6 both sides. Okay, and then we find the value of x. Then you can use Mr. Beloved calculator. You let me know in the comment section what is the value of x that you get. You divide both sides by the coefficient of x, which is 6. You get a beautiful answer of what? X is equal to 35 degrees. Okay, so hopefully O and N, you are also sorted now. You are sorted. It makes sense. You understand a little bit better why it is that we got 6x and why it is ultimately we got the value of x, which is 35 degrees. Okay. Okay, can I just check how many grade 8s? If you are in grade 8, please indicate in the comment section. Or if you are in grade 9, please indicate in the comment section. This is relevant for grade 8 and 9 learners, as I explained, or as I said to you. Okay. Yeah. That basically takes care of that. Okay. Right, so we have mostly grade 9s in here. Okay, and yeah, I don't know if there's anything else in particular that you would like to do, that you'd like to look at, my dear beloved friends. Okay, whereas any other particular section you want to look at, grade 9s? O and N transformation. What is transformation doing to you guys? Okay, look at this. This is an exam question. Okay, just let's look at transformation, then we'll look at some financial maths just shortly. Let's look at some transformation. Look at this. In the diagram, use the diagram given below and answer the following questions. So, on our Cartesian form that we have here, we have A, which is negative 2 and 4. Does that make sense that A is negative 2 and 4? Well, if you look at your vertical line that comes here, this is the x-axis, and this x value is negative 2, so it makes sense. Look at this C value. Its x value is negative 2. So on a vertical line, the x values are the same. You see? On a vertical line. Look at A and look at B. On a horizontal line, which values of your coordinates are the same? This y value is 4. Look at B on the same horizontal line. This y value is also 4. So this is telling us one thing, and that what that is telling us is that on the same horizontal line, your y values are the same. On the same vertical line, your x values are the same. So x is constant for a vertical line, and y is constant for a horizontal line. Okay, I hope that makes sense. Sorry, I just wanna... Had to clear some beautiful air there. All right, so we have all right, hopefully microphone is unmuted. I hope you guys can hear this. So we have A here, we have B there. So A is negative 2 and 4, B is negative 1 and 4. Okay, same horizontal line, like as I said, the y values are the same. Same vertical line, the x values are the same. This is important for you to know because it's important for not only this, but for functions as well. Okay, please be able to navigate your x-axis. This is where y is 0 on your x-axis. Then your y-axis, this is where x is 0 all the way. Now you have the ABC, it's a triangle. Those are the coordinates of the endpoints. Then you have P, Q, R, S. Now notice something, that this A doesn't have an apostrophe, this B doesn't have an apostrophe, this C doesn't have an apostrophe. But look at P, apostrophe, Q, apostrophe, R, apostrophe, S, apostrophe. So that means this particular quadrilateral has had a particular transformation applied to it. Okay? Now let's come down here. They are saying triangle ABC is what? Is reduced by a scale factor of half about the origin. And then they are saying draw triangle ABC. So that is the first question. Question number 8. So here what do we have? We have this concept of enlarge or reduce. So there's this enlargement or reduction that we speak about, and we speak about a certain scale factor. And they're saying it's a scale factor of half, and it's about, as they say, the origin. Okay, so that's just something to note there. I just want you to note that first and foremost. And then they're saying after we get the actual coordinates of this reduction by the scale factor about the origin, then we need to then draw the changed or transformed A, because we'll have gotten it, B, then we'll have gotten it, and C, and then we need to represent it on the Cartesian plane. So this is the current A, B, C, but then they want the changed or transformed A, B, and C when we have applied this enlargement or reduction, reducing by a scale factor of half about the origin. Then you look at 8.2. Okay, so here we have enlarging or reducing. So underneath the topic of transformation, there is what we call enlargements or reductions. Okay, and that's a concept in transformation geometry on its own. Then let's come here. Reflect. You see now we have another concept here. Reflect triangle ABC in the line y is equal to x to form the changed. Now we are applying another transformation. Now you might have noticed that here they put these apostrophes 1, 1, 1 per letter. Okay. Because this speaks of this transformation, which is reducing by a scale factor of half. So when you write these coordinates, they need to indicate, they need to be indicative of this enlargement or reduction. If you look at number 2, reflecting triangle ABC in the line y is equal to x. So we look at another type of transformation which we call reflection. Okay, and reflection can either operate as reflection in the x-axis, 1, 2, reflection in the y-axis, 3, reflection along the line y is equal to x. These are 3 different types of reflection, and there are certain things that you need to understand about them. All right? And obviously, when you have applied this reflection, it means that the coordinates of A, B, and C, as you see them here, are going to change, guys. All right? And basically you are going to have your 2 lines over A, 2 lines over B, and 2 lines over C to indicate this transformation. Okay, I hope that makes sense. Then lastly, here, quadrilateral PQRS transformed is the image of quadrilateral PQRS being translated according to the following what? Rule. How is it translated? X plus 1. So to the x, we add 1, y minus 2. So to our y coordinate, we subtract 2. Now this addition to x, or had it been a subtraction, speaks to the last type of transformation, okay, which we refer to as translation. But what is this guy saying? People be living a soft life, using your phone during exams. What is this? What are you saying? What are you talking here? What is this guy saying here? Okay, I think you're a detractor. I don't like detractors that come here and just comment, you know. I'm very quick to block and and mute people, yeah. So Tando, I don't know what you're saying. People be living a soft life, using your phone during exams. Okay, I don't understand what you mean there in the comment section. But anyways, and please don't come here with ideas that are what, you know. Don't really appreciate. People don't understand me here. Don't appreciate. Yeah, that's why I'm saying some people come here. So let's be kind to people that come here, but I will surely block them because I'm not really happy when people come here and just want to detract and say comments that are not really helpful to anything, anyone. Okay, guys, so I was saying this one, x plus 1, y minus 2. This here speaks to, to translation. Translation, there are 2 types of translation. There is horizontal translation and then there is vertical translation. And because, guys, I have to leave because I have a class, an actual physical class with my learners, I'm going to have to leave you right here. I unfortunately cannot answer this, but if you join my live session, maybe tomorrow morning when I have a live session, then I can actually go through the, what you might call this transformation geometry and explain it at length. But on my YouTube channel, I have a lesson on, guys, on my YouTube channel. If you go there, the link is in my bio. You just copy and paste the link. Copy the link, you paste it on the search engine, Google search engine. You copy the link, you paste it on my